Alright, this probability video covers the probability rules, and this kind of has double meaning here, right? Probability, the rules of probability, but it also mean that probability rules, like it's really awesome and totally fun. Obviously, it's the second option more than the first. So let's start going through the probability rules. We'll look at a couple examples, and then it shouldn't be too bad of a video. Alright, rule number 1. The probability of any event is a number between 0 and 1, where 0 means that there is 0% chance it will never occur, all the way to 1, 100% chance means it will occur in every single trial. So the probability has to be a number between 0 and 1. Typically, it's a decimal that you could turn into a percent. For example, right here in the middle would be 0.5, which means that there's a 50% chance that it would occur. That means if we ran 10 trials, we'd expect it to occur in 5 of them and not occur in the other 5. If we ran 20 trials, we'd expect it to occur in 10 and not occur in the other 10. Alright, change your thinking about what is unusually low. That's a pretty important point I want to make here, is a lot of kids think that anything under 50% is a low probability. That is not true. In this class, we want to start thinking that anything under 5%. So 5% or higher, anything above 5% is, to be honest, kind of likely to occur. Under 5% is when things start to get unlikely to occur. And that's what we're going to start kind of thinking about in class a lot. But regardless, rule number 1, the probability of any event is between 0 and 1. All right, rule number 2. All outcomes together must have probabilities that add up to 1. Some people call this the something has to happen rule. In any chance process, in any chance situation, something has to happen at the end. So if you add up all of those outcomes, you must get 1. So S is what we call the sample space. Sample space is a statistical way of saying all the outcomes. So the probability of your sample space is always 1. So your sample space consists of every single option, every single outcome at the end of your event, and then they must all add up to 1. That is rule number 2. Rule number 3, if all events are equally likely, the probability of event A is the number of occurrences that are in favor of A divided by your total outcomes. Now this is important because this is only if the events are equally likely. So let's give an example of an event that's equally likely. For example, rolling a die. Every single number on that die has a 1 out of 6 chance. So the probability that you roll a 3, well, there's only one side of the die that is favorable to rolling a 3, and there are 6 total sides. That's why the probability is 1/6. So just understand that this simple basic probability formula that probably everybody knows can only be used if the events are equally likely. So keep that in mind. Okay? Alright, the next rule, and we're actually almost done with the rules, the next rule is rule number 4. The probability that an event will not occur is 1 minus the probability that it will occur. We call this the complement. So, and we use a little c here, so you'll notice in my notation here, a little c. So A with the little superscript c there, that means the complement of A. The complement of A is simply not A, so anything other than A occurring. So the probability of not A, the probability of the complement of A, is simply 1 minus the probability of A. This is pretty easy to understand. If somebody tells you there's a 30% chance that it's going to rain tomorrow, well then that means there's a 70% chance that it will not rain tomorrow. So it's obviously just the opposite. 1 minus 30% or 100% minus 30% is 70%. So pretty easy to find the complement. It's just the opposite of it not happening. I'll give you one more example here. What's the probability of rolling a 3 when you roll a die? Well, we all know it's 1/6. We just got done talking about it. So the probability of not a 3 would be everything else. Any other outcome besides 3, which would be 5/6, because 1 minus 1/6 is 5/6. So that's pretty easy rule to understand as well. And rule number 5, this might be the, if any of them, the trickiest rule, because so far the rules have been pretty basic, but this is the one key rule that has a formula you kind of have to memorize. This is called the addition rule. The addition rule is used to find the probability of event A or event B occurring. And it's actually a pretty easy formula. I wrote it for you right here. I typed it up so that way it's very clear. The probability of A or B occurring is the probability of A plus the probability of B minus the probability of A and B. Now some kids get confused as to why you have to subtract the probability of A and B. It's because this A right here, the probability of A, might contain some A and also some B in there. The probability of B right here might contain some A and some B. So the idea is you have to subtract away the overlap. You have to subtract away the A and B. And if that still sounds a little bit confusing, trust me, by the end of this video, it will not be confusing at all. Now, in statistics, we have a couple important symbols. This U-looking figure, it looks just like a U. It actually stands for union. That is the statistical symbol for OR. An upside down U is the statistical symbol for AND. So another way of saying this formula is the probability of A or B. Now remember, this symbol means OR is equal to the probability of A plus the probability of B minus the probability of A and B. And this symbol right here, the upside down U, is the statistical symbol for AND. So be careful if you see those symbols. You just got to remember a U means OR, an upside down U means AND. All right, now this is also important. If A and B are mutually exclusive, if you remember in the last video we learned that mutually exclusive means that A and B cannot happen at the same time. Now, if they cannot happen at the same time, then that means it's impossible to get A and B. So that means the probability of A and B is 0. So the last part is really easy. So if you have two events that are mutually exclusive, you almost don't have to worry about this last part because the probability of A and B is 0. So just subtract nothing. It doesn't really matter. However, if A and B are not mutually exclusive, if there's some overlap, meaning that they can occur at the same time, you must find the probability of A and B and make sure you subtract it away. Now, this is a really valuable formula. In fact, if there's any formula dealing with probability that you need to remember, it's this one. Because this formula has 4 values in it that are really important to us. It has the probability of A, it has the probability of B, it has the probability of A or B, and it also has the probability of A and B. So as long as you know any 3 of those values, you could always solve to find the 4th. So that's why it's such a valuable formula. I will, of course, put it on a poster in my classroom, but also make sure you have it in your notes, please. All right, that's it for the rules. We're going to look at 3 examples here to help explain the rules. Hopefully my examples will make it really, really easy. But in terms of the rules, we're done. All right, here's a nice little chart here. This is just a two-way table, and when you were given a two-way table, probability is probably one of the easiest things you'll ever deal with. So here's an example of a question I can ask you. I could say, find the probability that I randomly select a woman from this group. So the first thing you're going to do is you're going to say, okay, well, there are 50 total people, and 30 of them are women, so that means that the probability would be 3/5. Obviously, you can make that a decimal if you wanted to. 3/5 is exactly 0.6. You can even make that a percentage and say 60%. All of that is true. I don't really care what answer you give me. Fraction, decimal, percent, doesn't matter to me. How easy was that? 30 women out of 50 total people, very easy. How about this one? What's the probability that somebody likes dance? What is somebody that's probability that somebody likes to dance? Well, 18 people like to dance out of 50 people, so there's my answer right there. Again, you could reduce this. Both are divisible by 9, so you could divide by 9 and get 2. I'm sorry, both aren't divisible by 9. What am I talking about? Both are divisible by 2, so you could get 9 over 25, and 18 over 50 is also 30.36, which is 36%. I mean, like I said, how easy is probability when you see one of these two-way tables? But watch out. I could also ask you for this. I could say, what's the probability that somebody chosen is a woman? Or, there's my U that means or they like to dance. Okay, here's where I have to use my formula for or. So the formula says, okay, let's start off with woman. What's the probability that somebody's a woman? Well, we already figured that out. 30 out of 50. That was easy. Plus the probability that somebody likes dance music. Okay, well, 18 out of 50 people like dance music. Now, the reason why I have to subtract should make complete sense as of right now. Here's the issue. 16 girls like to dance. Those 16 girls were counted in these 30 girls, so they got counted here. And those 16 people also got counted here because they like to dance. So those 16 people got counted twice. They got counted because they were women, and they got counted because they like to dance. And that's the overlap. And those 16 girls who like to dance deserve to be counted, but they don't deserve to be counted twice. So that is why we must subtract away the probability of and. The and is the women the people who are women and like to dance. 16 people are women and like to dance. They need to be subtracted once again because they were counted as women and they were counted as dance. That's why we have to subtract them away. It's not that we don't want them to count, we just don't want them to count twice. Okay? So hopefully that really hits home as to why we have to subtract. So I'm going to do 30 plus 18 minus 16, and I get 32 out of 50. 32 out of 50. 32 out of 50 would be 0.64 or 64%. You have to understand that when I say what's the probability of a woman or somebody who likes dance being chosen, this means that anybody who's a woman is part of this, right? I said woman or dance, so any woman would be part of this. Also, anybody that likes to dance would be part of this. Even the two guys who like to dance, anybody that likes to dance would be part of this. So idea is that if any one of those two groups is selected, I'm happy. So I need to count the 30 women, I need to count the 18 people who like to dance, but I got to subtract away that overlap, because that overlap, I don't want them to be counted twice. Okay? I could also ask you an and probability. And probabilities are really easy with one of these. I could say, what's the probability you're a man and you like sports? Now notice here, the and is that upside down U, man and sports. This is really easy. In fact, and are very specific probabilities. This is very specifically right here, the 10 men who like sports. That would be 10 out of 50. So we could ask you general questions, very simple, woman, dance. We could ask you or statements. We could also ask you and statements. Just be careful with or. Or involves the formula where you got to do woman plus dance minus any overlap. So hopefully that makes a lot of sense. And let's move on to our next example here. Okay, Venn diagrams could also help making this formula with or probability really, really simple as well. Alright, so here's a two-way table that talks about males, females, and do you have your ears pierced. So I'm going to make a Venn diagram here, and I'm going to make this left circle is going to be males. Okay, the right circle is going to be ears pierced. Okay. Now, the first thing I'm going to do is I'm going to start off with the overlap. Right here, where the two arrows are pointing, 19 people are males and have their ears pierced. So those 19 people will go right here in the middle because that's the overlap. Those are the people who are both males and have their ears pierced. All right, now, over here, this part of the circle over here, this is for males but don't have their ears pierced. That would be right here. These are the 71 males but don't have their ears pierced. So the 71 is very specific. Males and don't have their ears pierced. So notice that the entire male circle, 71 and 19, adds up to the 90 total males. Okay. On the other side, we have ears pierced but not a male. That would be right here. 84 people have their ears pierced and they're not males. Again, this is a very specific number. Ears pierced, not male. Well, if you're not male, you must be female. So that's the 84 people who have their ears pierced but are not male. So that entire circle needs to add up to 103, and it does. 19 plus 84 is the 103 people who have their ears pierced. Now, the outside of the circle would be you're not male, nor do you have your ears pierced. Well, bingo, that's the 4. Right here, the 4 are the females, because they're not male, and they don't have their ears pierced. So the outside would be 4, because they are neither male, nor do they have their ears pierced. So make sure you understand the 4 parts of this Venn diagram. Now, if I said, what's the probability? What's the probability that you are a male and you have your ears pierced? Well, that's easy. All you got to do is look in the middle there. 19 out of 178 people are males and have their ears pierced. What about the probability that you're a male or you have your ears pierced? Okay? Well, watch how the Venn diagram makes this easy. Males. Well, the entire circle for males is 90. So 90 out of 78. Plus pierced. The entire circle for pierced, having your ears pierced, is 103. out of 178. However, these 19 people here, they got counted twice. Because they were males, they got counted in the 90. They also got counted in the 103 people that had their ears pierced. So I'm going to have to come over here, or down here. Subtract away the 19 out of 178 that are both. That's the overlap. So it'd be 90 plus 103 minus the 19, and that would be the 174 out of 178. And that actually makes a lot of sense on multiple ways. First off, if you add up 71, 19, and 84, those are males and have their ears pierced, or males or have their ears pierced, right? 71, 19, 84. If you add those together, guess what you get? 174. Or you could think about, okay, I want males or have their ears pierced. The only people that don't satisfy that are females who don't have their ears pierced. That would be the 4. So the remaining 4 people that aren't included in the 174 would be the 4 people who don't have their ears pierced. Another way that you could think of where that 174 number comes from. So again, Venn diagrams make it really, really easy to understand this idea of overlap. And I really need you to understand that these 3 numbers, 71, 19, 84, and the 4, are all very, very specific values that are found using that two-way table. Okay, the last type of problem here is a little bit trickier because it's not based on a two-way table, it's based on percentages. But it's actually fairly easy if you just walk yourself through it. Here's an example. In America, 43% of people own a dog, 28% own a cat, and 12% own both a dog and a cat, or a cat and a dog. Make a Venn diagram. Alright, well the idea here is to start with the middle, because I know 12% own a cat and a dog. So let's have the red circle be, let me use a color there that we could see. Let's have the red circle be cat, and let's have the green circle over here be dog. Okay, now I know that 12% have both. So in the middle, I'm going to put that 12%, 0.12. You could write 12% if you want to. I'm going to use the decimal 0.12. So that's the overlap. That's the 12% of people that have both. So over here, this is very, very specific. This is cat only, no dog. So 28% of people have a cat, 0.28. If I take away the 12% that also own a dog, I'm left with 16%. So this part over here is you own a cat, but you don't own a dog. So the 16 and the 12 need to add up to the 28% that own a cat. So that entire circle represents owning a cat. Same thing for the dogs. 43% own a dog. However, I'm going to take away the 12% that also own a cat, and I'm left with 31%. That is a very specific probability. That's the probability that you own a dog, but you don't own a cat. So now you see how these numbers connect. The entire green circle adds up to 43. The entire red circle adds up to 28. The leftover would be the people that don't own a cat nor a dog. So if I take 100, or 1, right? Take 1, which is 100%, and get rid of the 12%, that's the people that own a cat and a dog. Get rid of the 31%, that's the people who only own a dog and not a cat. Get rid of the 16% of people who own a cat, but not a dog. So I'm taking 1, I'm getting rid of the overlap, I'm getting rid of both cat and dog, I'm getting rid of owning a dog and only a dog, I'm getting rid of only owning a cat. What I'll be left with is the people that don't own neither cat nor dog. So, and I get 41%. So that's the leftover, right? That's this outside part. So this outside part represents those people that don't own a cat nor do they own a dog. So now with these 4 numbers, which you can find is pretty much anything. So if I want to find the probability of a cat or a dog, again, notice my symbol there, the U for dog. A cat or a dog actually means 3 things. It means cat, it means dog, or it means both. Because if you own both a cat and a dog, and I said, hey, do you own a cat or a dog? If you own both, you're still going to raise your hand. That's how you have to understand that the formula does work. So it'd be dog, or let's start with cat. It'd be cat, 28%, plus dog, 43%, minus the overlap, because you don't want those people to be counted twice. So 0.28 plus 0.43 plus 0.12, I'm sorry, minus 0.12, my fault, would be 0.59. So 59% of people own a cat or a dog, which is why 41% don't own either. So 59% own a cat or a dog. Another way of finding that 59% would be taking the 16% that only own a cat, adding the 31% that only own a dog, and then adding the 12% that own both. Add those three numbers, you get 59%. It makes sense. And then if 59% of people own a cat or a dog, then obviously 41% don't own any or don't own either. So hopefully this video made probability really, really easy. Hopefully you understand the addition formula and why subtracting away the and is simple. Now the only thing I want to leave you with is that if you have two events that are mutually exclusive, they look like this. A and B. Mutually exclusive means there's no overlap. They cannot happen at the same time. So when you go to use the formula, the probability of A or the probability of B, you take the probability of A plus the probability of B. And since there is no overlap, you don't have to subtract anything away. You just stop right there. There's no overlap to subtract away, which is why when you're mutually exclusive, the probability of A and B is equal to 0 because there's no overlap. So if you're mutually exclusive, there's no overlap. The probability of A and B at the same time is 0. You don't have to worry about subtracting it away. All right, that's it, guys. Hopefully this video over the probability rules made a lot of sense, and hopefully you found out that probability certainly does rule.